Hi everyone, it's Mr. Baker here. Today we're going to be looking at calculating work done. Okay, so we're going to be looking at calculating stored energy, we're going to be looking at work done today, and we're going to be answering this question: what is work? So, how do we calculate how much energy an object is being given? So in physics, we say that if I've done work, then I've transferred some energy. So work done is energy transferred. So energy is measured in joules, and so work done is also measured in joules. So for example, if a person does 500 joules of work, then 500 joules of energy has been transferred. And in the same way, if a person transfers 250 joules of energy, then 250 joules of work has been done. Right, let's have a look at these two characters. Who's doing the most work? So you can see that the weightlifter on the left is really trying hard. You can see the perspiration coming off and is knocking knees because of how much exertion he's putting in. And the guy on the right there isn't looking like he's putting as much energy into this at all. So which one's doing the most work? Well, maybe a bit misleading. The weightlifter on the right is actually doing more work, and that's because the weightlifter is lifting more weight. So this guy in the blue on the right hand side, he's lifting more weight. You can count the number of weights there, and they've both lifted them exactly the same distance, so he is doing more work than the one that seems like he is working harder, and maybe that's because he's stronger. Okay, so one of the factors that affects work done is the amount of force that you've got to put in. The person on the right is putting more force in, more weight is being lifted, and so he is doing more work, more energy is being transferred to those weights. So the larger the force, the more work is done. How about this one then? We've got two people up a ladder. Let's assume that they are the same weight. We've got the person on the right there in yellow, and the other one that's in the red hat there in sort of greeny colours. So the one on the right is actually doing more work in this case, and if they are the same weight, then on the one on the right has moved further, and so the larger the distance moved, the more work is done. So another factor that affects work is the distance moved. So for the same force that's put in, then the further the distance you go, the more work is being done, the more energy is being transferred. And how about this one? So how much work is being done on the box? What do you think? So that box isn't moving, so they might be pushing really hard, they might be putting a lot of force into pushing that box, but because they're not moving the box and it's not moving any distance at all, then there's no energy being transferred to it, and therefore they haven't done any work on the box. So if the object hasn't moved, no work has been done. So how do we actually calculate work done then? So we use this equation: work done equals the force times the distance moved. So we've got these different quantities here. So force is measured in newtons, distance is measured in meters, and work done, we've said, is measured in joules. So let's have a look at an example. A cyclist pedals a bicycle with a force of 1,000 newtons, moving it 250 meters. How much work has been done by the cyclist? If you want to have a go, pause the video there and see if you can work it out. So I'm going to go through it now. So we've got our equation: work done equals force times distance. So this is how I would always do these kinds of questions. I would first of all write down the equation. You might get a mark for that. Then I would put the numbers in. So we've got a force of 1,000 newtons. So I've got force equals 1,000 there, and distance is 250. So I'd put those in. And then even if I used my calculator wrong and calculated it wrong, then I would probably pick up another mark there. But if I calculated it right, then I would have found that the work done is 250,000 joules, which we could say is 250 kilojoules, because kilo something is 1,000. So like a kilometre is 1,000 metres, kilojoule is 1,000 joules. So we've got 250,000 joules there. So if you tried it, I hope you got that one right. Let's have a look at another example then. So a car engine moves a car with a force of 10 kilonewtons, so that's 10,000 newtons, and does 500 kilojoules, so that's 500,000 joules of work. How far has the car travelled? So if you'd like to have a go at that one again, pause the video and I'll go through it with you in a second. Okay, so let's go through it then. So first of all then I would write down the equation again. So the equation is work done equals force times distance. Then I would put my numbers in. So we know that work done is 500 kilojoules, so that's 500,000 joules. We know that the force is 10 kilonewtons, so that's 10,000 newtons. So we've got 500,000 equals 10,000 times distance. Now what I need to do is I need to rearrange the equation to find distance equals. So distance equals 500,000 divided by 10,000. So 500,000 divided by 10,000 equals 50 meters. And this is the way that I would always go about these equations. So you'd get a mark for writing the equation down and maybe another mark for putting in the numbers correctly. And then even if you don't rearrange the equation correctly or get the answer right, then you probably still pick up a couple of marks there. But if you do manage to rearrange the equation correctly and then get those marks, you might get 3 or maybe 4 marks for that kind of question in the exam. If it doesn't give you the units, then you'll also need to write down the units and you might even get a mark for those. Okay, so this is what we should have been able to do by the end of this lesson then. So you should be able to describe what work is, you should be able to use the equation for work done, and you should be able to rearrange the equation for work done to be able to calculate some different things there. So what is work? So work is the energy that's transferred. And what happens when a rocket is launched into space? Well, when the rocket's engines are fired, the chemical energy in the fuel is transformed into kinetic energy, which is transferred to the rocket. The transfer of energy is called work. I just did those sound effects. Pretty good, eh? All right. Well, I've been Mr. Baker, and that has been work and how to calculate it, and I will see you next time. Thanks very much.